exam goings have come. Actually, in the links, please go ahead.
Yeah. Respected Professor and my dear students, I welcome you all to RISA DMB online academic activities today. We have ongoing exam preparation sessions now. Today we have discussions on our ASCII and practical exam afternoon session related issues. Without wasting much of our time, I hand over the session to our beloved Professor Sir. Over to Professor Nagaswamy Sir.
Okay, thank you. Actually, in the link, Dr. Kamachi has sent that we will be discussing ASCII, but there was a popular request to discuss about the anesthesia workstation and other topics of exam interest. So we will first go ahead with, there is no time for the last minute, we cannot be discussing in detail all about the anesthesia machine, but I thought we will make it a question answer session, asking about the important possible questions that you will get about the anesthesia workstation and then the components of the anesthesia machine. Strictly speaking, this topic of learning the anesthesia machine and workstation should be ideally taught to all the postgraduates after the first 3 months of their joining the course during the first year itself. Because when you go to learn driving in the driving school, first they teach you about the parts, how you get in, how you wear your seat belt, how to hold the steering, and what are all the troubleshooting you have to do if the car gets stalled, what are all the rules you have to follow to drive in the road. Like that, I think anesthesia also should be taught in a way that you first learn about the machines and then try to handle it instead of blindly aping somebody doing and then trying to follow the same footsteps. So so it may be a little surprising for you that this discussion on anesthesia workstation will be held today. I didn't purposely avoided informing that the class will be on anesthesia machine just to see how far you are all prepared to answer the questions. Okay. I share my screen. Okay. Is it visible?
Yes, sir. Yes, sir.
Okay. So can any one of you identify this machine and tell me the name of this machine?
Boyle's apparatus.
Boyle's apparatus, original Boyle's apparatus. What are all the things you find in this different from the modern workstations that you are using nowadays? All of you are very, very familiar with workstations because most of the corporate hospitals and even the government hospitals have started using workstations for the safety and good conduct of anesthesia for the patient's sake. So this is the old machine. Can anyone tell me the exact name of this model of Boyle's machine? Or just looking at the picture, can you tell me or describe what are all the things you are seeing in this machine?
Sir, oxygen and nitrous flow meter with pressure gauges, sir.
Flow meter. You straight away go to the flow meter. This flow meter is here. Okay.
Yes, sir.
Where is there any cylinder attached?
No, sir.
So the source of gas for this machine is what?
Cylinders.
How will you operate this machine?
Cylinders, sir.
Cylinders.
Cylinders.
Cylinder? How do you describe the cylinder? It's called the compressed gas cylinders. Okay, you should not just say cylinder. You should say compressed gas cylinders. And how many cylinders can be mounted on this?
4, sir.
How many?
4 cylinders, 2 oxygen, 2 nitrous.
Do you have 2 oxygen yolks here? Look at the
No,
picture
sir.
and tell me. No. You can see only 1 yolk Okay, this is called the yoke assembly where you mount the cylinders. I purposely wanted to put this picture because the current day students are not aware how to fix a cylinder in a machine, because in the workstation it is where do you find the spare cylinder in your workstation? The modern anesthesia workstations which you use, do you have a spare cylinder mounted in the compressed gas cylinder mounted in the machine?
Behind the
Backs.
workstation.
Yes, sir.
It is at the
The
back.
backside of the anesthesia machine.
Majority of the times it is not visible, isn't it? So here this is the basic model where you can fix only one cylinder in this and one nitrous oxide. You see at the back also you won't find anything extra. And how many flow meter tubes are here? Of course, the picture is in a profile fashion. I'm
Three,
sorry
sir.
for that. Three. You can see three bobbins here clearly. Even though you are not able to see clearly the flow meter tubes, you are able to see the three bobbins. So there must be three gases which can be accommodated. Okay. And what is this? What you see here?
Vaporizers.
What type? What is the vaporizer called? Somebody wanted some information on the history of anesthesia also. I think Muttumani wanted to know about the history of anesthesia. Questions on that also. So here and there you will get the
Goldman
history
vaporizer.
questions also. Huh?
Goldman vaporizer.
Goldman vaporizer. Very good. What are the characteristics or features of this Goldman vaporizer? Has it got any temperature compensation? What do you mean by temperature compensation of a vaporizer? All the questions are just like the exam pattern. I am not going to stick to the routine teaching method of starting from one end and going to the other end. This will be random questioning. I just want to all you to get used to this sort of pattern of questioning. So this is Goldman vaporizer. The answer is right. But what are the features compared to the modern day vaporizer? My first question, I gave you a clue also. Is it temperature compensated or not? Am I audible?
Yes, sir.
Yes, sir.
It is not temperature.
It is not temperature compensated. Why so much of hesitation to answer that? There is no method to compensate for the varying temperatures. Okay. So
Yes,
it is not temperature compensated. Is it agent specific?
Ether.
You
Only
can
ether
use any
can
agent.
be used.
Anything. You can use ether, you can use trilene, you can use halothane, because in those days only these three were available. So it was meant for any agent that you can use. Okay. And does it deliver an accurate concentration? What you said?
No, sir.
You said what?
Sir.
So this is a very, very basic model of vaporizer, which was used in those days before the modern vaporizers came. Okay. And you find this whole frame. What is it made up of? From the look of it, what metal or material it is made up of?
Iron.
Steel.
Huh? It is
Stainless.
steel.
Steel.
Stainless steel. Okay. And what about this wheel? What is this wheel called?
Caster.
Is there any peculiar? It is called caster wheel. Why you call it as caster wheel?
Anti-static.
Anti-static. Does it mean caster wheel? Anti-static is for the rubber bush that is there in that wheel. But when you say any wheel is a caster wheel, it should be able to rotate on all 360 degrees. Okay. The wheels that you have in your cycle or in your car, can they rotate all 360 degrees?
No, sir.
No, sir.
No, they can rotate only up to a particular, if at all you turn right, you may go up to 180 or 200. If you turn left, you can go on the opposite direction. But these wheels are meant to rotate 360 degrees so that you can push the machine in any direction in the limited space of the operating theater. Okay, so the original Boyle's machine is nothing but a steel frame mounted on 4 caster wheels with a provision for fixing a compressed gas cylinder of oxygen and compressed gas cylinder of nitrous oxide with pressure reducing valves, flow meters, and a non-compensated simple vaporizer and a common gas outlet. These are all the things that were there in the original machine. Okay, so nowadays you just see them in a very remote district hospital or a very old institution where people don't have funds to buy new machine. They may still be using it. Okay, so now what is the difference you find between this machine and this machine?
Pure reservoirs.
It has got some improvement here. You can now see the 2 pressure gauges here, one behind the other. Can you see that? And you can see there is a, what is this? The soda lime canister for circle system. Okay, and you have a flow meter with only 2 tubes, and you have 2 vaporizers. And this is, what is this vaporizer? Muttumani wanted history. So this is a historical picture. Huh?
Copper kettle.
This is a simple Boyle's bottle for ether. Okay, you can use only mostly ether in this. This is called the simple Boyle's bottle. Then this is a modern temperature compensated tech vaporizer for halothane. So this was a little bit advanced version of this older model with, because here when you have only 1 cylinder and halfway through you run out of oxygen, what will happen to the patient?
Hypoxia.
He will die of hypoxia. So they thought of that, and then, or had an accident like that, then they only stuck to them that you should have 2 cylinders, 1 in use and 1 in spare, and that is the reason why another cylinder was added. Okay, so this is the next model. Now comes another version. What is the change you find from this to this?
Sir, with the bellows, sir, for ventilation.
That's a ventilator. Okay, anesthesia ventilator is there. You find, what is this? Again, a soda lime canister is there. The flow meters are there, and you find provision for 2 cylinders are there. Then there are 2 modern temperature compensated vaporizers are there, and you can see the pressure gauge reflectors. So many are there, and then you find the monitor fixed on the top of it with a hook for your IV line. And what is this? Auxiliary oxygen flow meter. Okay, so this has become a little bit more advanced than what you saw, but you can see still the caster wheels are being maintained because we want to rotate or move the machine in all 360 degrees. We still have the caster wheels, the same thing is going on. And here we come to the more latest version of it, and you find all the other things fixed there, but you find everywhere it is covered, and you don't find any provision for fixing the cylinder, but you have to go at the back and see there will be cylinder fixed in that. And here you find only 1 pressure gauge for the cylinder because there was no central pipeline supply to all these things. Okay, or even if it was there in the 2 cylinder provision, there was no pressure gauge for the pipeline. But later on they introduced pressure gauges for the pipeline pressure also, so that you know whether you are getting a continuous supply, whether the supply from the main manifold, which is not visible to you, has adequate power and pressure for supplying continuously the gases that you require. Okay, so the number of pressure gauges display was increased. So this is how the slow evolution of the gases have come on. Now, why people switched over from the original basic Boyle's machine to the modern workstation? If the examiner asks you what are all the reasons for the innovation and usage of modern workstation, what are all the points you will be able to say? What are the advances that have been made in the workstation compared to your original basic Boyle's machines?
It has got pneumatic, electrical, and
Improve
electronic
safety
components.
measures, sir.
Very good. Okay. It is
It has got
components.
a monitor, and it has got safety features to prevent hypoxic mixture.
Very good. Excellent. Then okay, so we will not waste time. So safe provision, selection and delivery of anesthetic gases and vapors together with an appropriate built-in breathing system, and which is usually a circle system. This is the component. Second is provision of backup supply of gases. That is, always you have the spare cylinder at the back, and respiratory support in the form of sophisticated automatic ventilators. All the workstations nowadays come with a anesthesia ventilator also. Whereas in the olden days, we have to bag by manual. In our PG days, even a neurosurgery of 12 hours, 16 hours, we used to do manual ventilation. Imagine our plight, the way we have come up. Okay. Nowadays, you people immediately after intubation, you just flick the switch and then the whole patient goes onto the automatic ventilators. And monitoring machine function and settings is there. If the machine has got any problem, there will be an alarm or a indication that something is wrong. And we can also monitor the patient physiological variables because all the parameters are displayed in the monitors that are supplied with that. And there are even more sophisticated present day machines have record keeping automatically. You don't have to fill up the anesthesia chart all by yourself manually. Even for that, the machine will take care of. And the integration of display and auditory signaling. So there is a both visual and auditory signaling alarms whenever something goes wrong. And there is an appropriate provision to scavenge the gases. In the olden days, theater pollution was a very, very big headache. Nowadays, all the anesthesia machines, workstations come with a scavenging system to prevent theater pollution. Third, that ninth is there. Medical vacuum also is interconnected with that, and supplementary oxygen in the form of auxiliary flow meter, which can. What is the peculiarity about this auxiliary oxygen flow meter?
Without switching on the machine, we can.
Excellent. It doesn't require you to switch on the machine. It will even when the power is switched off, you use that, it will automatically work. And there are work surface and storage facility for everyday items, and provision of mains electricity sockets for low consumption items, and the association with delivery for like syringe pumps and other things. Okay, so these are the various modern functions of the workstation. If you remember at least half of it, then it will be good enough. If the examiner asks you what are all the advancements or the improvements made over the basic Boyle's machine. Similarly, there is a basic design. The very purpose of my showing you the picture from the oldest or ancient anesthesia machine to the modern workstation. If you have a close look, all of them basically have the same design. Only thing, a few updates or improvements have been done, but basically the machine has the same delivery systems. I will just start with one. Can you add on to the other one? This is a rigid metal framework on wheels. Attached to this is a source of compressed gas consisting of either a pipeline or a metal cylinders containing the relevant gases. So this is the basic thing for any anesthesia machine. Now, can you think of other parts in the designing of a delivery systems of this anesthesia machine? What is the other requirement? First, you require a rigid metal frame to which you must have a compressed gas supply. How are you going to deliver this gas to the patient?
Tubing.
Common gas outlet.
This compressed gas, is it at a high pressure or a low
Pressure
pressure?
reducing.
So pressure regulators for reducing the high pressures in the attached cylinder. So you just think of the way the gas flows. If you remember that, it will be easy to make your mind come to think of how the design will be there. So initially we need a compressed gas, either in the form of a pipeline or from the cylinder, but the pressures under which they are stored is very, very high, and you cannot directly deliver it to the patient. So these pressures have to be reduced. So we require pressure regulators for reducing the high pressure, either from the cylinder or the pipeline pressures are already reduced to some extent, but even that pressure is too high for the patient to directly receive it. So then we have what is called pressure regulators. Earlier they were called pressure reducers, but now because the outlet pressure is fixed and preset, they are called pressure regulators. Then there are secondary regulators to reduce further if they are going to be little more higher. For example, if the pipeline pressure is 45 to 60 psi, even that pressure you cannot directly deliver to the patient's lung. That will cause, if you deliver at that pressure, what can happen? Paratrauma, polytrauma, all these injuries can happen. So you may have to reduce it further to safe levels. So that is done by what is called secondary regulators. Then you must know what is the pressure that is being received from the pipeline or the cylinder. So you have pressure gauges. So the same thing. Even in the first machine, you had a pressure gauge. But in the workstation, you have multiple pressure gauges to show the pressure of both the cylinders, pipeline. So whatever source you are receiving gases to the machine, all of them are displayed. Then a method of metering this or allowing these gases to go to the patient. So you must measure and send it in so many liters per minute. So we have flow meter. Is there any change in the flow meters from the original one I showed it to the latest ones? What are all the advancements that have taken place in the flow meter? Somebody wanted to compare the old machine with the modern workstation. So how will you compare the
positions are from right to
Flow
left.
meter assembly.
flow meter assembly? Okay.
Points in the knob, sir.
Two tube design, sir.
So there are a lot of safety features in the flow meter system.
Proportionating device.
Anti-static measures.
Anti-static measures, proportioning recess, oxygen fail-safe alarms. Okay, all these things are all bit by bit part and parcel of it. But flow meters have now improved from a single tube to double tube methods, and in addition of gases. Earlier, the first picture I showed you, there were 3 flow meters, bobbins. What was the third gas? One was oxygen, other was nitrous oxide. What was the third gas? Were they using air like nowadays? In the old times?
Cyclopropane.
Carbon dioxide, sir.
Cyclopropane is not the
Sir,
one.
carbon dioxide.
Carbon dioxide, yes. Earlier
For-
machines had a flow meter for carbon dioxide. Why were they using carbon dioxide? In the anesthesia
To stimulate
machine?
respiration.
Excellent. Okay. So they thought hypercarbia will stimulate the patient because they were using only ether, and patients were quite deep and they had a almost respiratory depression. So they thought by giving additional carbon dioxide, they can stimulate the respiratory center and make the patient's spontaneous respiration revert back to normal. That was the idea. But later it proved to be hazardous because inhaling carbon dioxide is going to cause what change in the body?
Respiratory acidosis, sir.
Respiratory acidosis. Fantastic. So that is the reason why that has been removed. Cyclopropane was there only for a very short duration, and it was not Again, going back to the history, why it was not popular? Why cyclopropane went out of use very fast? What was the characteristic of that gas, cyclopropane, which made it unpopular? It's highly combustible. It can catch fire very easily. Okay, and it was very expensive. And because it was expensive, who introduced cyclopropane to clinical anesthesia? Again, history. It was one person called Dr. Ralph Waters. Tanni, Waters, Ralph Waters of USA. He was the one who introduced cyclopropane into clinical practice. And because it was very expensive, he found out the 2-on-4 canister, where you can remove the carbon dioxide using soda lime and reuse the exhaled cyclopropane back to conserve the cost. Okay, that is how the 2-on-4 canister was introduced into clinical practice even before your circle system for removing the carbon dioxide and reusing the exhaled gases to reduce the cost of cyclopropane. Any other contributions by Ralph Waters to anesthesia?
Canisters.
Huh?
circuit system.
Water.
2-on-4 canister
2-on-4 circuit, sir.
Huh?
Closed
2-on-4 circuit.
That's what I'm saying. 2-on-4 canister is the same thing what I told you just now. He introduced the 2-on-4 canister mainly to save the cost of cyclopropane. He was the first person to introduce daycare anesthesia. You know, he was such a popular anesthetist. What he did was he had a hospital where patients will be evaluated preoperatively as outpatient, and then they will be asked to come on the day of surgery. He used to call the surgeons and do surgeries like appendectomy, herniatomy, and all these things, and discharge the patient the same day evening. Even before we coined the terminology daycare anesthesia, he was the first person to introduce it as early as 1951. He had a center where cases were admitted in the morning and discharged in the same evening to save the cost for the patient as well as solve the problem of non-availability of bed in the hospitals. So he was the pioneer to do that, and anesthetist only introduced that. Okay, so these points you remember. And he also had a Waters airway to reduce the upper airway obstruction. Some of the pictures will be there, and the examiners may sometimes ask you that also. So the 3 contributions at least you remember: 2-on-4 canister, daycare surgery, and Waters airway. Then the system of attaching vaporizers. So vaporizers also have been there, but the quality and the delivery system of vaporizers has improved enormously. We were using 2 vaporizers, and simultaneously we could deliver both the inhaled anesthetics from both the vaporizers. But nowadays, what is the change that has happened in the modern workstation? Can you use sevoflurane and desflurane for the same patient at a time?
No, sir. No, sir.
No, sir.
No.
Interlock.
Why you are taking so much time to answer this? You all know that you cannot deliver 2 gases at the same time, or the vaporizers of 2 different agents cannot be used at the same time. And what is that system called?
Select the text.
It is called select a tech. You select only one. Okay. You select a tech vaporizer. What does the word tech stand for?
Temperature compensation.
Temperature compensated. So TEC stands for temperature compensated vaporizer. So select a tech. You select a particular temperature compensated vaporizer and use only one at a time. That is the latest version of vaporizers. Okay. And of course, earlier machines, there was no provision of any safety feature of a failure of oxygen supply. You have to all the time keep a watch on the pressure gauge to see how much the needle goes down to know what is the amount of oxygen left in the machine. But nowadays, What is the pressure below which the oxygen fail alarm will start sounding?
25.
30
30,
psi.
yes.
Okay, 30 psi is, even 25 is a little low. So 30 psi will be the lowest pressure below which it will start giving you an alarm that the oxygen pressure is falling. Take measures to correct it. And of course, there are measures to prevent the hypoxia by giving all the time 25% oxygen to the patient, because atmospheric air contains only 21%, but under anesthesia we always need a little bit extra oxygen, so minimum 25% should be supplied to the patient. So these two are very, very important advancements or safety features that have been incorporated in the workstations compared to the earlier machines. And there is a pressure releasing buildup of high pressures inside the circuits is prevented by pop-off valve, which can easily let out any high pressure. What is the maximum safety pressure above which the pop-off will release? This is another common question in the examination.
25
You must tell the unit also. For oxygen failure, it said 30 psi, pounds per square inch. But for the pop-off valve to release the high pressure built up inside the circuits, what is the value? It is 30 centimeters of water. Okay, here it is 30 psi, whereas for the pop-off valve it is 30 centimeters of water. And in the exam, one common question, you should be able to tell the equation. What is the value of kilopascals equal to millimeters of mercury is equal to centimeters of water, which is equal to the bar. This four comparisons you should be able to tell by heart without any mistake. So please read that. And I have shown it earlier in one of the ASCII slides also. And a system that bypasses flow meter for a high flow of pure oxygen in emergency. What is that called?
Oxygen flush, sir.
Oxygen flush.
Oxygen flush. Fantastic. Oxygen flush. What are all the safety features incorporated in the oxygen flush compared to the older machine?
It is placed slightly inside from the surface of the machine.
Okay.
Push button.
Okay. What is the most important point you have to say in this question?
Decoupling.
Supposing
100%
100% oxygen only we want to give. That is why oxygen flush is there. Supposing earlier machines, I don't know how many of you seen the old Boyle's machine, there will be a lever like thing, white plastic thing, which you have to rotate from upside position to down position. And if you keep it in that, the oxygen flush will be going on working. Okay. So it will continuously flush and give a high volume of oxygen at a higher pressure. Okay. So the common question they ask you is, well, how much liters of oxygen will be delivered and at what pressure when you activate the oxygen flush?
35 to 75 liters per minute at 55
35 to
60
60 liters per minute at what pressure?
Correct.
At the
55 to 60
pipeline pressure of 45 to
45.
60. Okay. So please remember, this is a very, very, very common question. Oxygen flush delivers 35 to 60 liters per minute of oxygen at a pressure of 45 to 60 psi, which is the pipeline pressure. So if you use it continuously, what can happen to the patient? If it is a short burst, okay, nothing will happen. But if you use it continuously, what can happen?
It can cause
Barotrauma.
barotrauma.
So in order to prevent that, nowadays the oxygen flush button is automatically recoil. You cannot keep it on like the older machines. Okay, self-limiting oxygen flush. It is called self-limiting. After 1 to 5 seconds, it will automatically come out. You cannot deliver oxygen at this high pressure and high flow for more than 5 seconds. So it's a self-limiting oxygen flow, oxygen flush, which is a very important safety feature to prevent barotrauma. And there is an inbuilt connection to circle breathing system to facilitate switch to single outlet of delivery of gases. This is called the common gas outlet. So if you see the design, starting from the gas source, whether it is going to be pipeline or cylinder, pressure getting reduced through a pressure regulator, and if necessary a secondary regulator coming through the flow meters, then through the vaporizers if necessary, and then coming out through the common gas outlet into the breathing circuits. So this is the basic design. Are you able to understand that? So whatever, however latest anesthesia gadget machine or the workstation you buy, this will be the common components in that. Without this design, you cannot build a anesthesia workstation, however superior, however big company you have. You can make small modifications here and there, add some more safety features, but these are all the basic things. Gas source, pressure regulator, flow meter, vaporizer, common gas outlet, and breathing circuit. So these are all the steps through which it should go. Is it clear?
Yes,
Have I
sir.
made it
Yes,
clear
sir.
for you?
Yes, sir.
Yes,
Is that
sir.
கொஞ்சம் உடனே
sir.
quickly answer, please. Otherwise,
Yes, sir.
I get no interest at all. Okay. So this is the another important thing that they will ask you is, what is the first thing you will check when you start using the anesthesia machine? So it is given in the if there is any possibility that the workstation or breathing circuit is a potential cause of difficulty with ventilation or oxygenation, switching to a self-inflating resuscitation bag is an appropriate decision. So ventilate and oxygenate first, troubleshoot later. This is the basic Taraka mantra every anesthetist should remember. And it is most important that verifying the presence of a working self-inflating resuscitation bag is very, 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 very important inside every operation theater where anesthetic machines are being used, or even if you are going to do a surgery under regional technique. So this is a very important point all of you should remember. In the exam they will ask you what is the first thing you will check when you start going into the theater. Always routinely check whether you have a self-inflating or an ambu bag in a working condition. Okay, because we don't use it regularly on everyday basis unless you have a theater from where you transport a patient with that endotracheal tube to ICU for mechanical ventilation post-op. At the time, sometimes we may be using this to ventilate the patient who is paralyzed and not breathing, or from a emergency room, you may intubate a patient and take him to anesthesia ICU or a post-traumatic metronome ICU, then you may be using this. But you should make it a habit to see that there is a good working ambu bag in the theater. Now this is the tracing the path of the gases and vapors. This is another important point. What I told you earlier. So source of gas supply, whether it is from the wall outlet or cylinder and from getting attached, high pressure reducing regulator, oxygen failure devices incorporated before flow meters. Flow meter is the beginning of low pressure segment, and vaporizers fitted next to flow meters downstream of flow. And finally, gases and vapors are delivered through common gas outlet at atmospheric pressure. So these are all the steps through which the gases come out from the pipeline or cylinder to the patient. So this, you remember this is the basic design what we have been talking all this time. Now the other common question they ask you is, how do you classify the various pressures in the anesthesia machine, or the segments
High
of pressure?
pressure system.
High pressure, intermediate
intermediate
pressure, and
system
low
with
pressure. Okay?
Intermediate pressure, low pressure.
So these are the three components. So the high pressure system, you must remember these points. Oxygen in the cylinder is 220 psi. What does the G stand for?
Pressure gauge.
Gauge pressure. So
Gauge
other
pressure.
common question they will ask you is, what is the difference between a gauge pressure and absolute pressure? There are two pressures. One is the gauge pressure, other is called the absolute pressure. What is the difference between these two? Now, when you say a full oxygen cylinder has a gauge pressure of 2200, what is the absolute pressure of this cylinder? The class is silent.
Sum of gauge pressure and atmospheric pressure.
Atmospheric pressure is absolute pressure, correct? Why so much delay in that? So what is the atmospheric pressure? How many psi? Atmospheric pressure is 150 psi. Okay, so it is 750-60 millimeters of mercury or 150 psi. So if you add this 150 to 2200, it will be 2350 psi. That is absolute. Why it is important means what the gauge reads is the 2200 psi. So after the gases are utilized, this gauge needle will come and drop to 0. So when you say the needle is showing 0 in the pressure gas, does that mean there is absolutely no oxygen at all inside the cylinder?
No, sir. No, sir.
No,
There
sir.
will be some amount.
There is some more oxygen is present still. Even when the gauge reads 0, there is some amount of oxygen left inside the cylinder. Why it is not coming out?
Because it has equaled the atmospheric pressure, sir.
Excellent. So there is a pressure gradient required. So when it is 220, it is more than 150. So it is going on getting delivered. When it comes to 0, the atmospheric pressure is 150. Cylinder inside pressure is also 150. I mean, the volume of gas that is there is also at 150 pressure. So there is no gradient, so it cannot come out. So how can you get that gas out? If you want to utilize that left gas also, that amount of gas that is present inside the cylinder at when the gauge reads 0, what is the
Heating
only
the
Increase the
method of
temperature.
Heating that cylinder.
not heating? Without heating, you apply suction and take it out.
Yes.
Okay.
Sure.
The only way of getting that gas out is to apply suction to the delivery point and take it out. Okay. So that is the very, very important point to know that the difference between gauge pressure and atmospheric pressure. Am I clear in explaining that? Are you all able to understand?
Yes, sir. Yes, sir.
This is
Yes.
a very, very common question asked in the examination. So please don't make any mistake. Gauge pressure means it indicates only the pressure inside the cylinder below the atmospheric level. So absolute pressure is gauge pressure plus atmospheric pressure. And because of that gradient only, the gases are able to come out from the cylinder. Okay. And then there is a nitrous oxide, the pressure is only 750 psi, but both are reduced to 45. But when it comes to the level of flow meter, what is the pressure of oxygen and nitrous oxide? Same 45 or something different? This is the first stage reduction. Whether you get a cylinder and supply the gases, or when you get a pipeline supply, all will be first reduced to 45 psi. But when it comes to the flow meter level, is the same 45 psi maintained or is it further reduced?
Decreased to 5 to
Decreased.
8 psi, sir.
5 to 8 psi is not at the flow meter level. It cannot flow out if you reduce it to 5 to 8.
16 psi, sir.
16 for what? Both oxygen, nitrous, same? Oxygen is 14 and nitrous oxide is 26. Okay, when it comes to the flow meter level, the oxygen pressure from 45 will be reduced to 14 psi, and nitrous oxide pressure will be reduced from 45 to 26 psi. So nitrous oxide pressure is slightly higher compared to the oxygen pressure. Why it is so? We will have to see how to prevent hypoxic mixture. Okay. So this is the important thing I told you about, how to convert the kilopascals into the bar to millimeters of mercury to centimeters of water and psi. Okay, and of course atmosphere. So this formula is very important. All of you should remember. PSI means pounds per square inch. PSIG means pounds per square inch gauge. PSIA means pounds per square inch absolute, and PSIA is equal to PSIG plus local atmospheric pressure. Why this word local atmospheric pressure is added here?
Adjusted to high
768
altitude.
C sure.
Ah, fantastic. It is between sea level and higher level. So if you go to a hill station and use the same machine, the ambient pressure will be much lower. So you have to know that and use that word local atmospheric pressure. So 100 kilopascals is equal to 1000 m bar, which is equal to 760 millimeters of mercury. That is the reason why 1 kilopascal will be 7.5 millimeters of mercury. Okay, this is the reason why you get that. And 10.3. So this will be equal to 1030. So if you convert all that, you will get 10.3 centimeters of water will be equal to 7.5 millimeters of mercury will be equal to 1 kilopascals. So that is a common change that you have to remember. That is so this is the effect of altered barometric pressure. So what will happen to the anesthesia machine if you use it at higher level is another common question that can be asked. And earlier machine, original Boyle's machine was manufactured by a firm called Cox. So this is the company which made that, and it was made by Gwathmy, Gwathmy. It's the person who first originally made the machine, and Boyle copied that and got the name. This happens almost in medicine, that somebody would have worked very hard and somebody else simply flicks that work and then publish it in his name and get the good name. So these are all the historical things that just for that purpose. And original types of anesthesia machine were called intermittent gas flows and continuous flows. And continuous flow machines are Boyle machine, Foraker, Draeger, and all our modern GE, everything comes under this. Now this is the person, Henry Edmund Gaskin Boyle, and this is the machine that he used. And you can see here in this flow meter, there is a orange color knob, and this is the one. This flow meter is for cyclopropane. Okay, so this gray color is for carbon dioxide, white for oxygen, blue for nitrous oxide. So there were 4 flow meters in the very old machines. And then you had the other same 2 pressure gas cylinders, and all these things were there. Now what is this? I don't know how many of you have gone to your hospital.
Manifold.
This is called the manifold room for storing. So small, high volume workload theaters, you cannot have small cylinders to supply the gases. So you go store them in a large cylinders and supply through central pipeline outlet. What is this? This white thing that is I am showing
Liquid
here.
oxygen cylinders.
Liquid oxygen plant. Okay. Sometimes they may ask you, what are all the criteria should be fulfilled to install a liquid oxygen plant in your hospital? Tomorrow you become a consultant and you go to a new medical college and they immediately give you an assistant professor job. And they ask you, we want to install a liquid oxygen plant. What are all the criteria or guidelines to install this? From this picture, what are all things you can see? Is it in the open or is it inside any shed?
Open area.
It should be kept always in the open. and it should be far away from the main buildings. Okay, and it should always have a good basic solid concrete flooring to bear the weight of the cylinder, and it will be fenced. People should not be able to go closer to that. It should always be fenced and kept away from that. And what is the name for this plant in medical terminology? Is the oxygen in a liquid form or gas form inside?
Liquid form.
Liquid form, sir.
It is called a liquid oxygen storage tank. So how does it come out as a gas?
When it comes
Whereas
in
the-
contact with the ambient temperature, it will
automatically it will become gas, is it? What is
Yes.
the temperature inside this liquid? Is it the same as the temperature of your small cylinder that you use in your
No, sir.
anesthesia machine?
No, sir. 183. No, sir. It's below the critical temperature.
118 is the cylinder, minus 118, negative. Okay, minus very, very cold. Minus 118 is the temperature of the gas inside the small cylinder, compressed gas cylinder, which we use in our E-type cylinder, which we use in our machine. Whereas this is minus 168. Okay, much more lower temperature. And this whole thing is called a VIE. What is the expansion of VIE?
Vacuum
Evaporator. Okay? So even though it is called as a liquid oxygen tank, the correct name for it is what is called VIE, vacuum insulated evaporator. Okay, so there is a heating element here, so much of connections you see, and that will allow the gas to come here and then get heated up, make it the liquid into a gas, and then there will be multiple pressure regulators to check the pressure and then deliver it at whatever pressure you want. All these attachments are there. So that is the basic thing that you should know. What is this picture showing you? Hmm?
Wall mount, sir.
Wall
Pipeline wall mount.
mounted pipeline outlet. The correct name is wall mounted pipeline outlet. What are all the safety features you see in this?
diameter
Index
Color
safety
coded.
system.
safety
Hmm.
System.
List.
What safety system?
Non-interchangeable screw thread.
Diameter index safety.
Diameter index safety system is one which you have to screw type.
Non-interchangeable screw thread, sir.
This is called the non-interchangeable probes, not screw thread. There is no thread or anything. You just like that push it inside. Okay. So they are called non-interchangeable varying diameter probes for insertion into what is this portion called? This portion in all these things. When you don't use this, will any gas come out through this?
No, sir.
So how is it prevented?
Tech valve.
There is a disc. Okay, so when you push this probe inside, the disc is shifted away and this probe goes in and it has got a hole here to receive the gas. Okay, so this is called the Schrader valve. This is the name of this is called the Schrader.
Schrader.
Schrader, Schrader valve. Okay, so this is the
Couplers.
probe. So when you
Yeah,
push
quick
this,
couplers. They're called quick
quick
couplers.
coupler or Schrader valve. That's also quick coupler is also not the correct name. And what is this?
Nuts and stem.
Nuts and
Body of the pipe.
body.
Nut stem body.
Where will it go? Where is it attached? You find
Cylinders.
there is one big opening. Huh?
Nipple of the cylinder.
This is called the valve block. Okay, valve block which is attached to. I'm not sorry, not the valve block. It is the pin index block which is attached to the yoke assembly, hanger yoke assembly. You have two holes pin index so that you can connect it upright like this also, or invert and connect it with the tube going up. Now here you find the tube is down, the hose is down, the oxygen hose is down and the nitrous oxide hose is down. So you can shift it up and also rotate it if there is a need for that. So this is the outlet for the gas from the hose, and these two are the pins, are the holes for the pins which have to be fixed at pin index holes for mounting it up or down, whichever way you want. Okay.
Okay, sir.
What is this called? Any
Pendant
anesthesia?
system.
Pendant, ceiling pendant.
Pendant.
This is called the ceiling pendant connector. What is tuck test? This is a common question they may ask you.
If
Uh,
you
Used to
put
test
pipe
whether
into
the pipeline is connected correctly and tightly.
if you pull
Once
that
supposing this hose you are pulling inside, to see whether you have fixed it tightly or not, you have to pull it and it should not come out. So how to remove this? If you want to remove this probe from this, what should you do? Can you just pull and remove it? Because
No,
tuck
sir, we
test
have
is
to
needed to see whether it is
out.
coming off easily or not.
You have to
So
press the
you have
outer.
to hold
have
this and rotate and then pull this. Okay. This portion, this circular portion that is there, you have to hold it and rotate it in an anti-clockwise and then you pull it out. Okay. So once you push it in and it is properly fixed, when you pull that, when you give a tug, that hose should not come out. That is a very important point that you have to remember. So this is the common components of the pressure systems. So they will ask you in the exam, what are all the components of the anesthesia system that are there in the high pressure? What are the components in the intermediate pressure? What are all the components in the low pressure? Can you quickly recall and tell me what are all the components in the high pressure?
Sir,
High
Gas
pressure
cylinder,
segment,
hanger yoke
gas
assembly,
cylinder or your pipeline supply. Okay, hanger yoke assembly where the cylinder is fixed.
cylinder pressure regulator, sir.
So all these
pressure
things.
gauge.
So hanger yoke assembly, cylinder pressure indicator or Bowden gauge and devices. Intermediate pipeline inlet connection, pipeline pressure indicator, piping, gas power outlet, master switch, oxygen pressure fail devices, oxygen flush valve, second stage reducing valve, flow control valve. All these things are intermediate. Low pressure from beyond the flow meter. So flow indicators, unidirectional check valve, pressure relief device, vaporizer mounting devices, and common gas outlet. So this is another picture of how the high pressure systems are there. This is the yoke assembly. For many of you who have not seen this, this is a lever which you can rotate out, and this will be the place where you fix the cylinder and hanger. This the whole thing is called the hanger yoke assembly. If they keep a machine and ask you to demonstrate the parts, they may ask you about all these things. And the washer inside is called the Bodak seal. And they may ask you about the Bodak seal. It's a non-combustible material and it has a thickness of less than 2.4 millimeter thick. Okay. And it has got an aluminum circle into which it is, what is the material out of which this is made? Is one of the questions. Neoprene, yes, very good. It's a synthetic material which will withstand high pressures. And this is the diagram of G aspire, and this is the diagram of Draeger. I'm not going to all that. Now this cylinder parts is another common favorite questions of all the examiners. So how is what are all the parts in this cylinder you can see? What is this called? This is called the valve block. Okay, and this is the valve head which you try to open. Okay, and this is the gas outlet, and these are the pin index holes. Okay, so the pin index holes are different for different gases, so that you cannot mount a wrong cylinder. And the components of a cylinder are body, valve, port, stem, and pressure relief valves. So this is also called the stem. And it is made up of molybdenum steel. Why it is made up of molybdenum steel? Because the answer is to increase the strength and weight is reduced, and wall thickness is also reduced. So this is another question they commonly ask you, why it is made up of this particular material. It increases the strength, reduces the weight, and reduces the wall thickness to withstand any high pressure. And you have aluminum cylinders for MRI compatible when you take a machine into the MRI room. And in this is the stem of it, this is the port, this is the pin index holes, and the conical depression you saw on the other side. This is the side which attaches to the machine. This will be the other side where the toggle screw will come and fix it to hold it in position. So this conical depression will be on the posterior aspect or opposite side to this. And this is the pressure relief device. And there is something called Wood's metal. Where will it be? Another favorite question in the examination. What is Wood's metal? Where is it present and what it is made up of?
The body and the
Cadmium, bismuth,
it is made up of
cadmium,
fusible
bismuth,
plug.
and
It
lead.
is also called fusible plug. It's called Wood's
Full
alloy
melt.
made up of bismuth, lead, tin, cadmium. Okay, and it will melt at 150 to 170 degrees, and that is incorporated. Can you see some threads here? Is it visible in the picture? Are you able to make out the something like a tightening thread?
yes,
So
sir.
you can see this thread, this whole valve block is threaded into the body neck of the cylinder. Okay, so this is the neck portion of the cylinder, and the whole block is threaded into that. And during the threading only, this Wood's metal is incorporated there, so that when temperatures become high, this metal will melt and the gas will start leaking outside through the side instead of causing an explosion. Okay, so that is the main purpose of adding that Wood's alloy to the screw portion of this or the threads of this here. That is where the Wood's alloy will be present. And of course, check valve assembly, all this, the various pin index numbers, they may ask you what is it for air, what is it for carbon dioxide, and cyclopropane is 36, and ethylene, helium, oxygen, nitrous oxide 152535. That is the easy way to remember. Air is 15, oxygen is 25, and nitrous oxide is 35. So these are the three things which are now using very commonly. So very easy to remember. Pin index number for air, oxygen, and nitrous oxide. And color coding, these are the things which are all very common. And this is what I told you about the screw to hold this cylinder in position. So this is called the toggle screw, and this is the transparent picture where you see how the gases will come out, and here in this picture you can see the threads nicely. So the whole wall block will be threaded into the neck of the cylinder, and that is where the Wood's metal is also incorporated. And these are the pin index safety systems to mount the correct cylinder. And this is where the whole cylinder, this weight of this is yoke assembly only bears the whole weight of the cylinder when it is attached there. So what are the dimensions of the pins? That has become a very fancy question nowadays. So examiners want to keep on increasing or finding out new questions so that to confuse the students. So what is the dimensions of
4 mm diameter, 6 mm length.
length? Is it the same for all?
Yes, sir. Big.
Interlock has a single pin and it is 7 mm long. Okay. Interlocks is also sometimes applied through the central nervous system, I mean central supply, through machines in some hospitals in UK. So it has got only one pin. All other things have got two pins. Whereas Enterox has a single pin and the length of it is 7 mm compared to the 6 mm of other machines. Now this is the what is this shown here, which you are using
Hanger
every day
to
nowadays.
assembly.
This is the back side of your anesthesia workstation with the same yoke assembly, okay, where you can see spare oxygen cylinder is fixed, and you have a nitrous oxide cylinder, and there is an empty yoke available for another cylinder to be fixed. And what are all these things?
Pipeline inlet, sir.
This is so the whole thing is called the panel. Okay, this panel, unlike the older machines where there is a separate attachment for cylinders and then a separate attachment for the pipeline supply, here they have incorporated all these things into one place. So that is this is how the cylinder valve looks like, cylinder yokes, and then this is another view of the thing with the this is showing extra something here. What is this? This is the yoke assembly where you can mount your cylinders. Immediately after that, you have something in metal color, yellow metal color. What is this? What you would not have seen in your machines. It is the back panel has been removed. The same thing, this panel has been removed. You can see the same outlets are there. So this portion, this entire metal portion has been removed. This is the pressure regulator. So if you remove this back panel, you will see the pressure regulator immediately after the attachment for both the pipeline as well as for the gas cylinders. So the back panel has been removed, and this is the latest single block manifold, again for the same attachments in another variety of machine called the bleached anesthesia machine. What are all these things?
Oxygen key, sir.
This is called oxygen key or keys for opening the cylinder. Okay, whenever a cylinder is attached to the machine, you need any one of them. Usually, you will have to use this particular key. This will go into that the stem of the cylinder, and you have to rotate it in anti-clockwise to open the cylinder and clockwise to close the cylinder. So that direction also some examiners ask you, how will you open it anti-clockwise, close it clockwise. Okay, so it's what is filling ratio and why it is important? This is another simple easy question commonly asked.
For nitrous oxide we use.
Filling ratio, the answer you have to give is
Weight of
applicable only
nitrous
to
oxide to
is applicable
nitrous
only
oxide.
to gases which are in the liquid form and which are vaporized to become a gas. Okay, so nitrous oxide is supplied in a liquid form which will vaporize and become a gas. Why this filling ratio is important? Supposing you have a nitrous oxide cylinder and you fill it up to the brim with the nitrous oxide liquid and manufacture that in a place where the ambient
Preventing
temperature is only
from preventing from higher temperature or pressures.
preventing explosion. Higher temperature it is going to expand. If there is no space for it to expand, what will it do? It will explode.
Pressure will increase and explosion.
That's what I'm saying. If you don't have, so you should not fill it to the full capacity. Okay, you always fill it to only about 0.75, and that is 75% or 67%, which is called 0.75 or 0.67, depending upon the climate or the ambient temperature area. So the filling ratio is the ratio between the weight of nitrous oxide in the cylinder to the weight of the cylinder when it is filled fully with water. That is the filling ratio. Filling ratio is the ratio between the weight of the cylinder when it is filled with nitrous oxide to the weight of the cylinder when it is fully filled with water. And it is usually only up to 75% or 0.75 in cold climates like UK. They will fill it up to 75%. Whereas in Indian climates, we will have to fill it only up to 0.67 or 67% to allow gas to expand so that there is no increase in pressure and cause an explosion. What other gas can be supplied in liquid form other than nitrous oxide?
CO2, sir.
CO2, fantastic, very good. What is the value for CO2? For nitrous oxide, it is 0.75 and 0.67, depending upon the ambient temperature. So it is also the same, 68%. Okay, filling density percentage ratio, weight of the gas in the cylinder to weight of the water, the cylinder will hold at 60 degree Fahrenheit. The temperature is also important. So the filling ratio is same for both nitrous oxide and carbon dioxide. What is service pressure and what pressure cylinders are checked for leaks? It's another question commonly asked the cylinders. What is the service pressure? It is the pressure at which the cylinders are filled. Service pressure is defined as the maximum pressure to which the cylinder may be filled at 70 degree Fahrenheit. Okay, and the pressure should be at least the structural strength should be tested at 1.60 times the service pressure. Okay, for example, if you are filling oxygen, maximum pressure at which you can fill it is 2200 psi. Okay, that is called the service pressure. But the cylinder should be able to withstand pressures 1.60 times more than 2200. Okay, that is what is called the check pressure for leaks. Right. What other tests are done at what interval? This is another question about the maintenance of the cylinders.
Hydrostatic test, sir.
Hydraulic test, not hydrostatic, hydraulic. So tensile strength, flattening test, bend test, and impact test. Okay, other than that, hydraulic test, tensile test, flattening test, and these are carried out at least 1 out of every 100 cylinders every 3 months. So when the company manufacturers say it is supplying 10,000 cylinders to various parts of our Chennai, that company is supposed to check 1 out of every 100 cylinders every 3 months for their safety. So that batch, it will be in batches. So if all the cylinders in that batch, one cylinder is ஒரு பானை சோத்துக்கு ஒரு சோறு பதம்ன்ற மாதிரி, you check only one cylinder out of 100 and then try to see whether all of the cylinders will be of the same capacity and strength. Okay. So what is critical temperature and critical pressure?
The temperature below which the gas cannot be compressed into liquid.
Very good. The critical temperature of a substance is the temperature at and above which the vapor cannot be liquefied no matter how much pressure is applied. Okay, that is the full answer. And the critical pressure of a substance is the pressure required to liquefy the gas at its critical temperature. Okay, so it is the pressure required to make the gas go into a liquid form. What is medical air? What is the definition of medical air? We are using air nowadays, isn't it? Very commonly we are using. So air that has no detectable liquid hydrocarbons and less than 25 parts per million of gaseous hydrocarbons and less than 5 milligram per square meter of particulates matters of 1 micron size or greater are normal atmospheric pressure and the dew point of 50 psi less than 4 degree. This is called the medical air. Because nowadays when you go to a petrol bunk and you want to fill your scooter or car with air, that is also air, but that is not medical quality. Okay, that is also compressed air. So low levels of nitric oxide found in ambient air may improve oxygenation in ventilated patients. That is the advantage of getting a purified medical air. Now, how to calculate when you are using oxygen and air mixture? What is the percentage? This is the formula. And, you can see how I am arriving at 2 liters of oxygen plus 2 liters of air is equal to 100. That is, oxygen is 100%. And the air has got only 21%. So 100 into 2, then that will be the calculation. So we'll get roughly 60.5% of oxygen will be there. So another common question is, what is adiabatic and Joule-Thomson effect? It's another common physics question that is asked. What is adiabatic and Joule-Thomson effect? When you open a cylinder, should you open it very fast or slowly?
Slowly,
Slowly,
sir.
sir.
When you use a small E-type compressed cylinder in your theater, when you try to open it, supposing settle pipeline supply has stopped, if you want to use this, always open it in a slow fashion. If you rapidly rotate and open it, what can happen?
The explosion can happen.
There will be a sudden release of pressure, which will create a heat energy. And that will, but energy will not be lost. It will be released, but it will not be, there will be no change in energy, but it can be the cause of explosion. That is what is called the adiabatic effect. And Joule-Thomson effect is for nitrous oxide. When you use nitrous oxide cylinder and open the stem of the nitrous oxide cylinder, and the valve releases the nitrous oxide gas vapor, what will happen? There will be a drop in temperature surrounding air. It will take the heat from the surrounding air to vaporize the liquid, and that will cause a reduction in the temperature, and water vapor in the air surrounding the valve will condense and form what is the frost will form around the valve block. So that is what is called the Joule-Thomson effect. So when a gas is subjected to sudden compression, the heat energy is produced rapidly, and the reverse occurs when there is a sudden expansion. There is no exchange of energy with the surroundings, and this is called adiabatic change. In Joule-Thomson effect, when the gas is allowed to escape through a narrow opening, there is a sudden temperature drop, which will cause frosting in the canister. What do you see here in this picture? What is this? Is there any cylinder mounted here?
Yoke plug.
No, sir.
No. So what have they done when there is no cylinder? Is it advisable to leave it open without any cover?
Yoke blocks.
No, sir.
Close with the yoke assembly.
This is called dummy, also known as blanking plug. Okay, this one. See, these are all the small things when the examiners ask you, and if you don't answer, they feel very elated. This very small thing we asked, even that if they are not able to answer, they feel very happy, sadistic. Okay, so this is called the dummy plug. Whenever there is no cylinder attached to the whole thing is called the yoke assembly, and it should be always kept covered to prevent any dust or oil particle going there, which can be the cause of combustion. And this is the old C3H6. What is the formula? Cyclopropane. So this was a very old machine where cyclopropane assembly was there. This is carbon dioxide. You can see the name written here. So nowadays they are not using it. So they have covered it with what is called the dummy plug. Then there is a non-interchangeable. Of course, this is a closer view of the pin index holes and the outlet for that. And immediately after that outlet, there will be a check valve to prevent any. What are the limitations of the pin index system? Can you cheat the pin index system and fix a wrong cylinder in the machine?
Yes, sir.
If you
By
do very
inserting.
well, some examiner, what are all the methods by which you can cheat the yoke assembly and fix a wrong cylinder?
By inserting one or more Bodox.
Borax seal, very good, excellent, 1 point. And
Wrong
any other
gas filling
method?
in the cylinder.
Wrong gas filled in the cell, that's a manufacturing problem. But with the machine, when you are using, okay, so a wrong cylinder can be placed in the yoke if 2 washers are placed on the bore and the pins of the yoke are broken or holes in the cylinder valve are too deep. If these holes are very deep, then the pin can be easily fixed into that. So the 3 reasons why you can fix a wrong cylinder to the wrong yoke also is 2 washers or pins are broken in the yoke assembly or the holes in the cylinder valve are too deep. What is this?
Borden's gauze.
This is a Borden pressure gauge. Very good. What are the safety features in this?
Anteriorly,
All
it
questions
has
mainly
a
will be safety features only.
Covered by tough glass on the anterior side.
Pardon?
if the pressure increases, it
Covered tough
ruptures
glass.
only posteriorly.
Okay. There are so many safety things which you have to say. That's only one of them what you are saying.
Color coded it comes in.
See, the name of the gas for which you have to use is written here. There is an instruction, use no oil, and there is a warning signal that you have to replace the cylinder if the level of the needle comes down here, and it shows full cylinder pressure here, 2200 or 2000 roughly, and usually it is a white color indicating the color code, or pounds per square inch is also, it is written both in pounds per square inch. Nowadays you get it in kilogram per square centimeter. Okay, so that is the unit it will be there, and this is the inner picture of how this whole thing works, and it is a simple. Any of you know what is this?
Whistles. Riches.
Whistle, sir.
This is a
Riches.
whistle which you see in the villages or even in the streets. When you go for take your child outside, you blow through this, the whole thing will roll out and it will produce a noise, and once you take off the pressure, it will again roll back to its original position. So the same principle is there in this also. Okay, by this pressure it is getting stretched and it moves the pointer. And this is the person, Eugene Borden. So it's named after him in the Borden gauge. And this is the nitrous oxide cylinder. So the safety features are, it is color coded, name and symbol are written. If the tube ruptures, it will went only posteriorly, as I said. Gauges are angled and placed in a solution position where you can read it easily. And instructions like no oil, open the valve slowly, all are written on the gauge. And here, as I told you, here it is in kilogram per square centimeter, not on pounds per square inch. And these are all the various pipeline connections. This is how the backside of your workstations, where you can get the nitrous oxide, oxygen, air connected from the central supply, as well as there is a spare cylinder attached. This is a pressure reducing device. So this is how the old machine pressure reducing devices look like, and there is a vent for here, so that any excess pressure will be leaking out through that. And there is also a safety relief valve here after it comes out. So from the pressure gauge beyond that, it is going to come, it gets reduced, and then there's a safety feature here in the pressure regulator itself. Then there is a safety feature here for relieving. So always they take care to see that high pressures don't go to the patient. They are all vented out if there is any decrease in the pressure. And this is the mechanism how it is working. And these are all the earlier types. Again, for history's sake, Adams pressure regulator was used in the past, and it was same principle but a little bit different, because the fins in the Adams regulator of nitrous oxide are not present in the new regulators. And then there were Mckeson's Medishield endurance valve and modern type of pressure relief valve, which are direct and indirect. And of course, safety features, as I told you, all are they have the modern anesthesia machine regulators have got this particular special material, polytetrafluoroethylene. So PTFE coating on the diaphragm together with a nitrile, which is a hard synthetic rubber on the valve seats, and chrome plated brass for regular body. So these are all the advancements that are made in the pressure regulators. These are the components. And coming to the oxygen flush is another question that, as I told you, it will deliver gases anywhere between 35 to 75 liters per minute, the volume, and its purpose is self-closing device and designed to minimize unintentional activation, and it is labeled as O2 plus. Instead of oxygen flush, it may be written as O2 plus also. The hazards are it may cause barotrauma, or it may dilute the inhaled anesthetic, and it will cause internal leakage, and sometimes the flush may be stuck. So in the older machines, this is the type it was there. So if you press this button, it may get stuck inside and keep on activating it. So what they have done is they have modified this like this. You can see it is written not as oxygen flush but as O2 plus. And here you can see it is flushed with the surface. Whereas here they have got another rim like thing. So this button cannot be easily approached unless you put your finger. Whereas here, your elbow, if you are careless, you can just activate it. Whereas here it cannot be done. So that is another important thing that I have increased. So workstation standard requires that oxygen flush be self-closing and designed to minimize unintended operation by equipment or personnel. The modern design of oxygen flush button is shown here. This is the modern design. That the button is recessed in a housing to prevent accidental depression, and the valve is self-closing. This is the inside picture of how the whole gas comes directly from the thing. Now this is this picture I have taken from a very old machine. After you remove that stainless steel top in front of the flow meter assembly, if you take out that, you will find this will be the picture. So why I have put this picture here is, in some hospital they may still be having this type of old pictures, old machines. The examiners will definitely want you to identify. Just because you are using workstation and you are used to that, they will not excuse you if you are not able to identify the parts of an old machine also. So I have rubbed out the answers here. There are arrows pointing to various things. Just look at them and try to tell me what all they are pointing at. What is this is pointing at?
Nitrous oxide pressure gauge.
Nitrous
Golden
oxide
gauge.
pressure gauge. Very good. What about this?
Oxygen burden gauge.
Oxygen pressure gauge.
You can say oxygen pressure gauge also, not necessary to say Borden gauge all the time. Oxygen pressure gauge. What about this?
Oxygen pressure
Pressure
regulator.
regulator.
Oxygen pressure regulator. Similarly, this
Nitrous
Nitrogen
oxide
pressure.
pressure regulator.
nitrous oxide pressure regulator. Very good. What about this?
Master slave
These
mechanism.
inside connections are only little tricky. Okay. So here you have one connection. Here you have one connection. Here you have one connection. And here you have one connection. So these four things are very easy. Pressure gauges, pressure reducing valves are easy. What about the other three inside things? One goes to the ventilator, one goes to the oxygen fail-safe alarm, one goes to the closed circuit. Okay, and this is the common gas outlet. So I'll just show you the answers also here. This is the oxygen pressure gauge. This is the nitrous oxide pressure gauge. This is the pressure regulator for nitrous oxide. This is the pressure regulator for oxygen. This is the low pressure alarm system. This is this connection. And this is the connection for ventilator outlet. This is for closed circuit outlet. And this is for oxygen flush. And this is fresh gas outlet. So remember the three inside connector. One is for low pressure alarm. Another is for ventilator connection. Another is for the closed circuit connection going to the circuit system. And the fourth one is the oxygen flush. These four only are little difficult. All other things are very easy. And if they show you this machine and ask you to identify, please remember all these points. So how to calculate the amount of gas in a nitrous oxide cylinder? So the answer for that, you have to use what is called Avogadro's hypothesis. 1 gram molecular weight of a substance will occupy 22.4 liters at standard temperature and pressure. Okay. So the weight of a oxygen cylinder, nitrous oxide cylinder is 5.6. What do you mean by tare weight?
Weight of empty cylinder.
Weight of an empty
Empty
cylinder.
cylinder. Very good. So empty cylinder is about 4.5. With the nitrous oxide, it is 5.6. So the weight of the nitrous oxide is 1.1 kg. What is 44 grams? How do you arrive it?
Molecular weight.
One molecule of
Molecular
nitrous
weight.
oxide.
What is the molecular weight of nitrogen?
14.
14, sir.
14. So 2 into 14, 28. Molecular weight of oxygen?
16, sir.
32.
16. So
16.
44 grams.
Yeah.
So 44 grams will occupy 22.4 liters. And the amount of nitrous oxide you have is 1.1 kg. That means 1100 kg. So 22.4 multiplied by 1100 divided by molecular weight, and the amount of nitrous oxide vapor or gas you will have is 560 liters. And if you give 2 liters of nitrous oxide per minute, you will have this cylinder running for about 280 minutes, which is 4.6 hours. Okay, so this calculation also sometimes they ask you. And how to calculate the volume of oxygen in a full E-type cylinder?
Boil.
So the
Boil.
same thing. So the temperature here it is Boyle's law. You use the Boyle's law. Here for nitrous oxide you use Avogadro. For oxygen, at least remember that you will use Boyle's law even if you are not able to expand and say all these things. Please remember these points that you have to use. And how you can use it based on the pressure. You can say if the cylinder capacity is 660 liters, the oxygen is about 660 liters will be there, and that will be with a full pressure of 2000 psi. So if the pressure has dropped down to 1000 psi, 50% has reduced, then what will be the liter of oxygen inside? Pressure has reduced by half. So what will be the volume?
Reduce it by
It will also
330
reduce by half.
330.
It will also reduce by half. Okay, so that is how you solve. Now what is shown here? This is about your modern anesthesia workstations. Where you
Master
have
switch.
some, master switch. Very good. So this is a master switch which activates the workstation. So how does the glass flow increase in flow meter? How are you able to increase the gas supply, the flow meter?
You have to rotate it anti-clockwise.
You have to rotate it. So in the valve control valve, it is called valve control valve. So that is another thing they may ask you is of how what are all the safety features in the flow meter system. Okay. So it has what is the name of this flow meter tube?
Torpis.
Harpish.
Thorpe tube, Graham Thorpe, Thorpe. It's called the Graham Thorpe tube, and he made it a tapering inside. Even though it looks cylindrical from outside, the inside is tapering, so smaller at the bottom and larger at the top. As it goes on expanding. Okay. So what factors govern the flow of gases in the flow meter? This is another physics question. They will definitely ask you. What are all the
English.
So
rate
density
of flow?
with density low laminar flow with
Ah.
viscosity low laminar flow, density high turbulent flow, sir.
Turbulent flow. So there are three important things that you have to remember: pressure drop across the constriction, size of the annular opening, physical characters, and this low flow. What are all the laws involved in that?
Eigenpoisson laws.
Again,
Graham's law.
Eigenpoisson and Graham's law. Very good. Okay. What is this? What is shown here and what are its advantages and disadvantages?
Scavenging.
Hmm?
Scavenging.
Not able to hear you properly.
Scavenging, sir.
Scavenging. My God. You see a pressure gauge here, you get a knob with a symbol to increase and decrease. You see a number, there's a flow meter like tube. How can you call it a scavenging? And you have a color coding. What is the color code for this?
Green for oxygen, sir. Yeah, yellow for
Oxygen.
air, sir.
Air. Blue for
Nitrous
N2
oxide.
nitrous oxide. This is American standard. Yeah, in America, they use only green color for all oxygen related and oxygen coding. Air for yellow and blue nitrous oxide. So this is an electronic flow meter, okay, which has got this control knobs. Advantage, it has which it can be connected to the information system on data management, OT data management. And disadvantage, it works on electricity, so you require a power connection. And what is this tube for? What does it indicate? Now you see you have 2 liters of oxygen, 1 liter of air, and 1 liter of nitrous oxide.
Gas flow.
So this shows the total flow. Okay, instead of having, so these are all replacing the individual flow meter, and this is the one to show you the total flow, so that you can corroborate whether your flow meters are working properly or not. So this the tube is for total flow measurement. Okay, and this is the two system tube. What you are seeing in your modern machines, you have two flow meters, one for low flow, another for high flow. And they are connected like this. And again, both of them are tapered like this. You can see the difference in the inner diameter, smaller here and larger here. And then the gases come through this and then start flowing this. And the total flow has to be read from here. If you are using high flows, you have to take the reading from here. But if you are going to use low flow less than 1 liter, you can take the readings from here. But the control knob is the same for both. You don't have separate control knob. So this is called the two tube design. Whereas here you can get the low flow also, but high flow also in the same tube. That is called the dual taper design. So up to 1 liter, the tapering is different. Beyond 1 liter, the tapering becomes different. So this is the why. What the question they may ask you is why this Graham torque tube is tapering inside. Is it only to differentiate the flow or some other reason?
So decrease the force of gas.
Decrease the size of the tube. Okay, otherwise you will have to have a very long tube. So by having this tapered inside, torque was able to reduce the height of the flow meter tubes. That is the advantage. Now what is shown here?
Air and oxygen flow meters.
Air and oxygen, is it a regular flow meter or something extra?
Auxiliary ports.
This is an auxiliary. So it is an auxiliary flow meter found on a workstation, and you have for both oxygen and air. If you want to give lower percentage of oxygen, you can mix both and give. What is this yellow arrow showing?
Air outlet.
This is the outlet. This is the air outlet for oxygen. See, it is here, and this is what is this green?
Oxygen outlets.
Green arrow. It is not a mask. Showing an arrow. Are you able to see that arrow?
ACGO.
That is the diameter index safety system connection separately for that. Okay. So it is a self-contained flow meter with its own flow control valve, flow indicator outlet, short tube with maximum flow of 10 liters per minute, usually on the left side of the machine. Okay, so it will be usually on the left side of the machine. It can be used to supply oxygen without turning on the machine. And the old machines were working on pipeline supply. In the newer one, it works on cylinder and pipeline both. So that is the difference between the older oxygen, auxiliary oxygen, and the newer oxygen machine. Then of course, oxygen failure safety valve measures are there. How they work? They are working on what is called pressure sensor cutoff. Just in the exam, you will not have time to explain everything. So at least remember the name. It can be working on a principle called pressure sensor shutoff valve. So it works on the threshold. And another method is the usually 30 psi. Manufacturer's threshold is 30 psi, and immediately the alarm should happen within 5 seconds. That is the standard specification. And in the Omida, it may be 28. In Draeger, it is 30 to 37. So each manufacturer has got a little bit of difference in that. And the older one mentioned is the pneumatic alarm system, which is called Bowman's or Ritchie's whistle. So they used to, when the pressure drops, it goes to a small chamber which has got an opening, and through that the gas will start leaking and you will get a whistling noise. So it is called Ritchie's or Bowman's whistle. These are all pressure failure devices. What is shown here?
Proportionating device.
25, sir.
It's called Link 25 system. Okay, it is also called Link 25. Whenever you say, you must say this particular name only. It is called Link 25 system because it is linked to oxygen nitrous oxide or linked to deliver 25% of oxygen minimum. Okay, so that's why it's called. So they are all called hypoxia prevention safety devices. Earlier there was a thing called mandatory minimum oxygen flow. For some time in all the workstations, they were supplying it with a minimum mandatory flow of 50 to 250 ml to prevent hypoxia. So that patient will get at least a basal oxygen requirement of 250 ml per minute is the basal oxygen requirement. So they wanted to supply that. But this started diluting the gases, and when they started practicing low flow anesthesia, this became a hindrance because the machine will, whether you like it or not, deliver this amount of oxygen. So for low flow anesthesia, it became a headache. So they removed this now. So we don't have this anymore, but it was there for some time in the earlier versions of the workstation. Now, minimum oxygen ratio is the one where you will definitely be achieved or guaranteed more than 21%. And this is by the mechanical linkage. So you find there will be two sprockets, one for the oxygen and one for the nitrous oxide. And the nitrous oxide will have lesser number of teeth in the sprocket, 14 tooth, and the oxygen will have 29. So when you rotate oxygen, nitrous oxide will be only half the time rotated. So the amount of gas coming out will be less than what you rotate, release from the oxygen. That is how it is working. So it is always guarantees a minimum of 25%. If you answer that much, it is enough. And the another method of preventing hypoxia in the Draeger machine is the oxygen ratio monitor control, which is sensitive oxygen ratio controller, which works on the principle of the valve adjustment with the diaphragm. So there is an oxygen chamber. Of course, exam you can't describe all these things, but at least remember the name ORC, ORMC or ORC, which is oxygen ratio controller. So they are the hypoxia prevention devices. The earlier ones what we showed is all for preventing oxygen supply failure to the machine. Okay? So that is the difference. And this is the common gas outlet, different types of common gas outlet, and this is the circuit changer switch from closed circuit to open circuit whenever you want to use pediatric circuit for babies. You can use this outlet by changing this. And this is the ridge which was tension. So this oxygen O2 plus valve is inside, doesn't get affected. And this is a common fresh gas outlet, which usually 15 female slip joint fitting with coaxial 22 male connector. So this measurement also sometimes they ask you. And at the common gas outlet only, the pressure delivered is 5 to 8 psi. All other areas it is more than that. So please don't make a mistake. It is 30, 14, 26, and finally 5 and 8 psi. Okay. So this is the older machine with the ether and trilene. This is the back bar. Mainly the reason for showing this picture is to show the back bar. So this was the older machine back bar where these vaporizers are permanently fixed. You cannot remove them. So flow meters deliver the gases and they will come through this and then come into that. And this is the oxygen flush I told you. That is, this is the activator for the oxygen flush in the older machines. And this is the newer machines where the back bar, the vaporizers are fixed. So these are some of the safety features in the anesthesia machine, like color coding, safety tin index system, safety relief valve, filling cylinders, loading pressure gauge, pressure reducing valve. And these essential features of a modern anesthesia workstation quickly. This is non-interchangeable diameter index safety system is there to prevent the incorrect connection. Then thin index safety system for cylinders. So this is for central pipeline supply. DISS is for central pipeline supply. PISS for cylinders. And low oxygen pressure alarm. Then hypoxic guard. So this is for detect oxygen supply failure to the common gas inlet. And here it is for preventing delivery of less than 21% to oxygen to the patient. So this is the difference that you have to understand. Oxygen pressure alarm is for detecting the failure of oxygen supply to the machine itself, to the pressure gauges itself. Whereas hypoxic guard is preventing hypoxic mixture to the patient. Then oxygen failure safety device or proportionate is again for administration of nitrous oxide or other gases when oxygen supply fails. Again, that is preventing hypoxia to the patient. And then the oxygen analyzer, which comes along with all the workstations. This is the most important very, very important safety measure that has been incorporated so that you know whether you are giving the right quantity of oxygen required to the patient, irrespective of the flow meter or the flow rate that you keep. If this is working properly, you will know whether you are giving adequate oxygen or not. And there are automatically enabled essential alarms and monitors. Vaporizers interlock. This is the selector tech switch. Then capnography and anesthetic gas measurement. Exhaled gas measurement is available in most anesthesia workstations. An oxygen flush mechanism, which will not harm or cause a barotrauma. That way it has been designed. And breathing circuit pressure monitor. Airway pressure monitors are available, which will detect high peak and negative airway pressure. Then exhaled volume monitor is there to assess the ventilator working or not. And lastly, you have the pulse oximetry, blood pressure, ECG, and mechanical ventilators which control alveolar ventilation, battery backup, and scavenging system. All these things are what are called the essential safety features on a modern anesthesia workstation. So if you remember some of these points, if they ask you in the exam, it will be easy for you to answer that. Okay. So that will close the discussion on machines. To my knowledge, what are all the common questions that you can anticipate in the examination?